As a follow-up to my previous video on the topic of using QGIS and lake temp data as an additional resource to predict freeze dates for ice skating, I'm going to teach how to get the raw data that was used to determine the mean values in the aggregated data set. Now, don't necessarily expect too much from this primary data set. It's really more in regard to what temperatures and whether or not the water, quote unquote, was observed. So in the previous video's description, there was a bunch of URLs that had the T's in the HTTPS changed to X's. And the reason for that is so I don't have to upload my identification to YouTube and have it kept on their server for 2 years. The same thing will be in the description of this video or at the end of the video as a card if you want to watch the previous video for some reason. So after my last video, I had a number of people message me that they use macOS exclusively, and there were enough people that said that to me that I just decided to load a fresh installation of QGIS onto this machine, which is running macOS. For time and simplicity's sake, I have only added the layers for OpenStreetMap for the WMTS, and then lake temp _aggregated_v1. So without further ado, let's just get into it. So I'm going to click on identify, or actually, no, I'm not. I'm going to pan the map a little bit and click on identify features. And first we're going to go to Tustumena Lake. One day it will load. There we are. By the way, this video is also a one take. So there we are. That was my phone beeping. So here's our HydroLake ID for Tustumena Lake is 402. And for whatever you're doing on your end, if you want to follow along, that's fine. Just either note this down somewhere or remember it in your brain. 402 Tustumena Lake. Next, either Skillack or Skylack Lake. Correct me on my pronunciation, please. There we are. Skylack or Skillack Lake is the ID is 4605, so we have 402 and 4605. We're going to pan over to Kenai Lake, which I'm fairly certain I'm pronouncing correctly. And this will be the last one for this example. Just waiting for it to load. .402 is Tustumena, 4605 is Skillack, and now we have 4577 for Kenai. Next, if you're on Mac, as I am, we're going to open terminal, and I got to that by pressing Command space. Oops. And real quick, we're going to open up Finder, or wherever our lake temp _v1 folder is. And we're going to change directory from wherever you are to this folder. And the way that you'll know which directory to change to is it'll be at the bottom here. Mac OS X, users, bishop, GIS, lake temp _v1. So we're going to do CD for change directory, and then // users / bishop /GIS//lake temp _ v1, enter. Now that we're in that folder, what we are going to do is we're going to type awk -F apostrophe, sorry all you computer science nerds, comma apostrophe, and the -F apostrophe comma apostrophe is basically our CSV delimiter, which allows us to get what we need from the file. Then we're going to type apostrophe nr equals 1, and that is essentially copying the row 1 header for the data. And then we're going to press space and do a double pipe, and space again, and $1 == 402 for testimonial. The $1 is just saying that it's the rows where the first column equals 402 for the HydroLake ID. Then we have 2 pipes, and we're doing the same again. Oopsies. For Skillac was 4605, space, pipe, space, $1 == it was the last one, 4577, can I? And we're going to close that off with an apostrophe. Next, we are going to look over here. So the file that we want to draw from, or that we want these commands to go to, is lake temp _ primary _ v1.csv. So lake temp _ primary _ v1.csv, and then we are going to create a new file only containing this data. Also, I made a mistake up here. Can I on Mac? Yes, I can. Go team. Whoever is texting me will just have to wait. All right, we're going to call this Alaska _ primary _ subset, or whatever you want, .csv. And just double check everything is correct. Yes, it is. Enter. So now in this folder, we should see this being generated. At the moment, it says 0 bytes, but that's all right. We're going to go into the lake temp doc. So the lake temp technical doc, and under 3.1 for the primary data set, this is everything pertaining to the values that are on that spreadsheet that we are creating. And it looks like it's good. So we're going to open up Chrome, in this case, go to File, Import for Google Sheets, upload, and just drag, come on team, drag and drop, import data, just leave everything as is, and cool beans, Google, don't care. So all of these temperature values are Celsius multiplied by 100, and I don't want to do that math constantly, so we're just going to write a quick and easy function for this. If is number in C2, then we're going to take C2 and divide it by 100 and output that. Enter, and yes, we want that autofill. So now we have everything in Celsius over on this side. And real quick, for our water, for our D column under water, there's 4 possible flags that we can have here that are explained in this area right down here. I just like to do things from memory because it's testing myself. Anyway, so 1 is water, which means it's a good data point. 2 would be land, which is a bad data point. 3 is the surface is unknown, and 4 is that there was no information available, but they still chose to include it. And then for the outliers, there's 3 possible flags. 0 is within the accepted range, so that's good. 1 is a extreme value compared to all the other data, and that doesn't mean it's a bad thing. That just means that it's potentially still good. And then 2, if it's a 2, then you should disregard it. So to make this all easier, we're going to go to D and create a filter. Click on a filter, and we're going to uncheck 3 because 1 is good. And there's a whole lot below this that isn't 1. So now we have Now we have our lake ID. So 402 is Tustamina, and then 4577 is Kenai, and 4605 is Skylac. And then we have the date and time of when the remote imagery or remote sensing data was taken. And then we have whether or not water, quote unquote, was there. And we have if it's within the accepted range, and also what the temperature of that reading was for that surface temp. So this would be useful for, was it freezing or not, right? Anyway, that's the most simple way to do this. And you could just create a larger file here by just getting more numbers for creating your own CSV file from the primary data set. So this way you're not trying to load all, I think it's 1.4 or 14 million cells. And there is a way to open this up in QGIS. I just don't think it's excuse me, I don't think it's as useful as doing it this way and just generating your own CSV file either via terminal or the command prompt. And if anybody is on Windows and needs to understand how to do this in command prompt, let me know. I can just as easily create a video on that. Well, if you found this video helpful, like, comment, subscribe, or don't. And this is the anomaly video, and have a beautiful winter when it finally comes, and enjoy skating and be safe and all that jazz. Farewell.